What was that?
Don't worry about it.
Okay.
That was his shotgun.
The Chinese.
So, you guys can answer.
Well, actually, I'll show you guys something funny real quick.
Chinese
Gonna
ball.
smoke us with it.
This is something that we wrote in 200 today.
Do you feel some like Rick Astley in there? You re-roll something with that? Oh man.
I'm surprised it didn't crash.
Yeah, GameStop's gotten a lot better.
Yeah, what the hell is she doing?
Yeah.
You know what you should do? You should make like 3 buttons and like empty like randomness.
All right, let's see. Let's see what people said. Lexical analysis so that scopes are kept track of.
A+.
Compilers must recursively traverse code that is made up of statements within statements, etc. Therefore, it is helpful to use a recursive function calling itself, which benefits from the stack. That's not horrific.
I am written back.
Acid? I can only assume your first answer.
You just wrote one of the 3 stack functions.
Well, that's the thing.
I didn't ask you which stack function. I said
You
which.
said which function? That's
No, which.
Uh-oh.
Feature.
What feature of modern compilers does the stack data structure help us support?
Oh, I don't think I answered that right either. I think I used
All right.
writing.
We use the stack because it is last on, first off. We can take off the first.
Yeah.
We can take off. We can take off the first item, or just simply look at it. This is useful for. We use the stack to support the list of tokens that we could iterate through, and we used peeking to allow for look ahead. Look ahead's the correct answer.
Oh man, that's what the boot does. It looks ahead.
The syntax analyzer, we pass a stack of tokens around, kind of like an environment. And that's not like horrifically wrong. It's just like why? Why do we pass it around like an environment? So that's mediumly wrong. Help us support error checking / syntax can check ahead to compare what is expecting and what is actually there. Blah, blah, blah. That's correct. Look ahead. She said everything but look ahead. And when I mean she, I mean Carrie. All right. Syntax analysis using look ahead. I'll read the rest just out of respect. Using the stack while matching statements of the source language grammar. All right. Well, Scott got it right. Well, we're on Ian now, so so we can be able to pop, push, peek at items in the data structure to be able to read the things.
It sounds like a dance.
Modern compilers help support the pushing and popping. There's 2 P's in popping, Dane. Of the stack. Line and Objective-C are built in methods to help with the stack. It's made up. Linear processing, continue processing piece by piece to the end of the code. Statements. Stacks allow the compiler to go through source code and only look at one statement at a time before. That's going? Oh, moving. Before moving on to the next one. Reminds me when I was in high school in a driver's ed class, like the classroom class. We had this one kid in the class. He was not overly bright, and we did it. We had like quizzes or whatever in there, and we'd exchange papers, and then he'd read off the answers, and we'd grade each other's papers. Well, somebody was grading this guy's paper and took it up to the teacher. So I can't read this answer. The teacher looks at it. He's like, hey, car. Then it looks like cheese. I'll accept it. Hey, for all you know, he's been a perfect driver. All right, so the stack helps us support look ahead. How does it help us support look ahead? Well, first of all, what is look ahead? Okay, so this deals with expectations along the lines of the grammar. So we can look ahead to see what is the next thing. This is most obvious from last class when we were dealing with our if and the if with the else following it, right? So there's kind of two different productions which involve the starting special symbol if. One of them is if, followed by whatever, blah, 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 followed by an else. The other one's if with no else. So we used look ahead to figure out which of the productions this was matching, or if it didn't match any production. Today we're going to talk about syntax errors a little bit. So given that, why is a stack ideal for this? What are you looking at, Simon?
Mm-hmm.
Turn your screen around. Oh, now you have to turn around.
I'll send you the link.
No.
Later.
He's just gonna put it up on the recording.
Yeah.
No, I won't put it on the recorder. I just want to see what's more important than my words.
Like ants.
Hold on, let me search golf.
So he's going to quickly search PGA rankings or something like that. I like the commercial with Bubba Watts in it for the PGA.com, the new technology they're using. Bubba's sitting there, they're explaining to him about the new technology, and says, oh yeah, you get live tweets and all this stuff, and Bubba's sitting there, and live updates of all players, things that are going on in life. Bubba's like, well, how live are we talking? He's like stuffing a donut into his mouth. And all of a sudden his weight goes up by a pound. He says, look, see, you just got fatter. You guys are good. So why did we choose a stack? Why is a stack ideal for this? Well, first of all, did it have to be a stack? Let's ask that question first. It didn't have to be a stack. I mean, you could implement anything using almost anything in programming in roundabout ways, right? You know, you can do something iteratively, or you can do, like for instance, recursion. Some problems really lend themselves to recursion, but the rule of thumb is anything you can do recursively, you can do doing iteratively with a stack. Okay, why? Because that's how recursion is implemented. So all you're doing is redefining recursion on your own. Okay, so why a stack? What about stacks lend themselves to this type of problem? Go ahead.
One by one, not losing order.
You can do that with an array. You can do that with a linked list. You can do that with a queue.
Keeping the scope. Keeping scopes organized.
You're just using the word scope because you think it sounds compiler-ish.
No, it's easier to follow. You only deal with things that are in your scope, and then when that.
When we pop something off the stack, when we're doing our look ahead, we pop something off the stack. So let's use our if-else structure as an example. So we find the if, if is followed by a statement, then it's optionally followed by an else, correct? So we pop the thing, we pop the if, we see, oh, we got an if. So then the next thing we're going to do is we're going to pass the stack around like Jake told us to do. We're going to pass the stack around, and we're going to process a statement from that stack because that's the next thing we're expecting. But ultimately, when we return control back to where we've seen the if, when we're dealing with the grammar, we need to deal with the possibility that the next thing on there is an else. But it might not be, right? So what are we going to do? We're going to pop the top of the stack off. We could also peek. But let's just do the whole mechanical aspect of it. We're going to pop the thing off the top of the stack. We're going to check, is this an else? If it is, then what are we going to do? Well, we're going to continue processing the production that is the else. It was good that we popped it off the stack, correct? So we took the else, now we go process statement, pass the stack along, blah, blah, blah. But what if we pop it off and it's not an else? We got to put it back, okay? Because we reached into the cookie jar and took out a cookie when that wasn't our cookie. It was a who? It was a raisin cookie. I like raisin cookies.
I know, but if what? Raisin, it's a bad surprise.
I mean, I guess I can see your point. Okay, but the point is, so we popped something off the stack that does not belong to us. We were checking it, we were doing the look ahead, but since it's not what we want, a stack gives us the convenience of pushing it right back onto the top of the stack. It's right where it used to be. We don't have to worry about push and pops, no big deal. Stacks are very simple data structures to write. They're simplistic. I mean, it would not be unreasonable for me right now to give you a 5-minute quiz and have every one of you write a stack that holds integers. This would be a very easy thing to do. Half of you wouldn't be able to do it, but that's an embarrassment. Okay? But a stack is an extremely simple data structure to write. But the power in the stack itself, problem solving with the stack, is where the real power is. Okay, so a stack really lends itself to this idea of being able to pop something off the stack, deciding if we need it or not, then pushing it back onto the stack. That make sense? So looking ahead a little bit, if we're thinking about dealing with syntax errors, how does our look ahead technique also help us deal with syntax errors? Let's use the example. Let's say we are in the middle of an if statement. So we read in the word if. After an if, and here I'll jump back to our list of grammar. So here's our if. And as of right now, remember we're ignoring the expression portion of this in our simplified language. So an if is the word if, followed by an opening parenthesis, followed by a closing parenthesis, followed by a statement. If we read an if, and the very next line we see does not have an opening parenthesis, we have a problem. The very next token we see does not have an opening parenthesis, we have a problem. That allows us to deal with syntax errors. That's walking through our code one token at a time. So if we had some code that looks like this, let's say, if, let me give myself just like a text box. Let's left justify this. Right, Joey? Hello. Man, with these shakes, I'm so bad at clicking. Only with my thumb. If I click with my index finger, it works. But my thumb, sometimes I go to like make it go down, and it whatever my twitching and stuff is makes it move on the thing as well. It's messed up. How do I even play golf? It's an embarrassment. I should just go to play tackle football. I don't need to use that the dexterity for that. It's just blunt force trauma.
Joey's usually the quarterback too.
Is he? But I'm not fast enough for that. I need to be within phrasing. I need to be within a certain distance. But yeah, what I do is I once I get up, I just go dead weight. Drag him down, and then just like wherever I fall on him that's where the leg breaks. Yeah.
Alright, so say you're a down line,
Mm-hmm.
I'm the quarterback, and that's too great a distance. I mean, what distance are you going to find that's shorter than that?
Well, no, actually, I'm pretty fast for short distances, but I'm not like going to run you down.
Maybe you will.
I'm not that fast. I have very good acceleration for very short distances.
So there's no offensive line?
If you're within 10 feet of me, I have a chance, unless you're already in a run.
Right.
But if you're like in the pocket and I have an opening and you're 10 feet, I might be able to get to you. But like, let's say you run by me. Chances are I'm not going to be able to turn around and run you down.
Right. But it's going to be hard to get around you because you got the big wingspan.
I know, seriously. Plus, I grab helmets and stuff. I don't care about those rules.
Oh.
Well, not helmets. I grab hair, other appendages, just whatever I can get my hands on.
I've heard that you're quite the grabber, yeah.
What's this? Hey, Ali, what's up? You missed a quiz. Everybody failed it. Didn't matter. So the only thing you did is just not embarrass yourself publicly. All right. So if we're processing this, our stack is going to look like this. I mean, really, this is what my stack looks like. Okay. So we have these guys. We pop the first guy off the stack. We have an if. If we see an if, we're going to be in that production of our code. So taking us back over to our code and our source reader. Here's our match statement. So if we're looking at the reserved word if, we'll be in this else if here. So the next thing we're expecting is an opening parenthesis, right? So that's what we're going to try to match next. So we're going to pop right here. Now, as it stands right now, what do? Whatever we popped, we just spit back out, correct? So we'd be spitting out bad code at this point. But we want to be able to respond to this. So whatever we just popped off, we know should be an opening parenthesis. We even put the comments in here, right? If it's not, we can throw a syntax error right now, can't we? Now think about how compilers work. When you run your compiler, does it show you all the errors in your entire program, or does it show you just the first error it came upon? Think about it.
Doesn't just show one error. Show you that.
Well, here, let's.
I'm trying to run 30.
I'm going to go into driver.
It will crash in the first place. Yeah, that's what you're talking
I'll say if, then I'll say if, then I'll say if, then we'll do an opening, closing. Okay, so it's fine with this guy. I hover over this, it says syntax error on tokens, delete these tokens. Goes to this guy, delete these tokens. Okay, what if I put the opening parenthesis here? Now what's it doing? It's saying expression expected after this token. So it's expecting an expression. When I left the opening parenthesis off, the error fell to here. But notice it's also giving me errors down here. So what if I put an opening closing parenthesis there? Now it's saying I'm expecting an expression here, right? Expression expected after this. What's it saying here? Syntax error on token if, delete this token. So it is giving me future errors, correct? What if I come down here and I say int a and forgot to put the semicolon after it? Looking, what's a semicolon, right? So our modern day compilers, specifically the ones that have real-time compiling, you know, that's really been the advancement. The compilers themselves work this way now as well, but when we had to implement real-time compilation like we have in Eclipse, Eclipse kind of works like Microsoft Word works. When you make a grammar error, it underlines it, right? Without us actually compiling. Where if we were using the command line Java compiler, we can write all sorts of crap code for 20 minutes. Then when we go compile it, we find out about how horrible we are. So Eclipse gives us the benefit of giving us, you know, real-time feedback as to what crap we just wrote. So historically, as far as syntax errors go, compilers would just give us the first error it ran into. Why keep looking if your current version of the code is crap, right? Modern compilers give us, I don't know if it's fair to say all syntax errors, because it still has to choose a path that it needs to go down based on that it's compile time instead of runtime. So it might not necessarily give you all syntax errors, but it should give you many syntax errors, not just the first one it runs into. I think that's at the very least a fair statement to say. So if we're looking at our code, actually we are in our code. This is just bad code. Okay. So if we're in our code here, or actually let's go to Keynote, just deal with it at high level. If I read in this token, everything's peachy, right? There's nothing wrong at this point. If the very next thing I read in, though, is this guy, I was expecting an opening parenthesis, but I read in that guy. That's an error. I have two choices. I can spit out saying we have an error, or I can toss my errors someplace. Does that make sense? I can throw that error onto a stack, onto a linked list, store it somewhere so I can show all the errors that I found later on. And then I'll keep going. So what we can do is we can assume that we read in what we were supposed to read in. So I was supposed to read in an opening parenthesis. So the next thing I'm expecting is a closing parenthesis. Well, when I don't read in that, we're going to have another error. Expected closing parenthesis. So on and so forth. Now, we see in our compilers that we don't get that kind of feedback. If we look at Eclipse, it tells me to insert the closing parenthesis. What if I forget even the opening parenthesis? Syntax error, delete these tokens. So it doesn't tell me that I'm missing both the opening and the closing parenthesis. It's just confused. When I give it the opening, and then it's expecting an expression, which this is an expression. It's specifically a Boolean expression, but so it found the if, it found the opening parenthesis, it found the Boolean expression. Now it tells me I'm expecting the closing parenthesis, and I didn't find it because the next thing I found was this guy. So our compilers, when they give us syntax errors, they're actually giving them to us in a fairly intelligent way. That's been a major improvement in compiler technology over the years. And this is where the skill set in debugging comes in as a programmer. If you were writing code 15 years ago, let's say, and you compiled something, you would get an error message. Now that error message, back then, may not necessarily correspond to where your error is. It might be somewhere farther down the program where the error is first, where the consequence of the error is first noticed. For instance, a good example of this might be uninitialized variables. So if you create a variable int a and don't give it a value, that's actually not, well, it's never an error because they do get default values, but let's just assume for a second it is an error. That's not realized until we go and try to actually use a as a value before we actually gave it a real value. So in Eclipse, what do we get? We get a warning, variable may not have been initialized or something like that. And if you ever ignore that, then you're being a bad programmer. You should never, 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 never rely on the default value. It's a horrible practice. Do you do that? You rely on the default value sometimes? Are you lying to me?
I'm not lying to you. No, I'm not that kind of person.
Simon, turn your laptop around.
No.
Still? I don't know about you people. Okay, so what's the correct way to handle syntax errors?
You can do like one of those inline things to tell the compiler to ignore that section, and you can just keep going without the error message popping up.
If you run into bad code, just ignore it. I'm sure they didn't mean it.
Yeah, that's what I've been doing in my projects.
That makes sense.
I haven't tried to build yet, but I assume the best.
From a programmer's perspective, what kind of syntax errors do you prefer? Assuming you're going to have syntax errors.
Missing some hard ones to
Do
solve.
you want to know about all of them? Or do you want to kind of hit them one at a time until they all go away?
I would say all of them. Because sometimes like, you can have multiple syntax errors caused by one. So if you can look at all of them, realize which one that is, fix it in that one place, then all the other ones go away.
Mm-hmm.
Whereas if you look at them one by one, you might say, oh, well, this is wrong, I'll fix it. And then that changes other things in the code, causes more problems. And
Yep.
you can cause more problems than you fix.
Okay, so your argument is that the more information the programmer has available to them, the better. They can apply their own logic to it and see, okay, I have 30 errors, but you know what? As I look at this, 27 of them are caused by this one problem. Yeah, I would tend to agree with that. The more information we can give the programmer, the better. So when we're actually writing our compiler and we're giving syntax errors, if we run across an error like this where we, an if statement is missing the opening parenthesis or something like that, do we immediately output that? Do we store it somewhere? Do syntax errors need to be stored? Right now, when we're going through our compiler, we're just spitting stuff back out to the screen, right? We're matching the different productions, and we're spitting it out to the screen based on what we expect, just to prove that we walked through it in the correct order. So given that we know what to expect, we can then throw a bunch of if statements in here to check, is this guy this guy? You know, is this guy a opening parenthesis or something? You sleeping? Are you lying? So we can do that and just print it out to the screen as soon as we recognize they didn't have an opening parenthesis. Or we can store it in a stack someplace or store it in a linked list, however you want to store it, and then print it all out at the end. Do we have a necessity to store our syntax errors? Or do we just need to let the end user know about them?
Know about it.
You know, are we going to need to use those syntax errors again?
You should store them all and send them to that person's professor so he can make fun of them.
We only store stuff in variables if we need to use them again, correct? And when we come across a syntax error, we're going to let the programmer know on the screen, but we're not going to, we're not going to have to use it again, are we? So let's do this just for the if statement, just so we can see this kind of in action in the last few minutes of class. So I'm going to go into source reader, and we're going to do this for our if. So we're going to go ahead and right here we're going to say if. We'll probably come up with a better way of doing this, but just for the time being, I'm going to say if parts at bucket 1 dot equals. Well, actually, I don't need to do. No, it is a string. Dot equals opening curly brace. Then we'll spit it out. Else. System dot let's do system dot error dot println. So we'll have it in red. It'll look all awesome like. Expected opening parenthesis. Something like that. All right, so we'll just throw that one error in there for right now, just when we forget the opening parenthesis. Now we're going to go out to our terminal. Go into my first program.simon. And here, I'll go ahead and I'll remove that opening parenthesis here for our if. All right, and I'm actually going to add another if in as well. That's missing the opening parenthesis. Actually, hold on, this isn't the code we're working with right now, is it?
No. We need a lot more simple. It's
It was
like my
Simon
first.
2
Yeah.
or whatever. No. Yes.
All right, so we'll give ourselves a syntax error here, and another syntax error here. So on both of those, we forgot the opening curly brace, or opening parenthesis rather. I'll throw another if statement in, if, and that one we won't forget the opening. All right. We'll go ahead and run our program now. So we should get 2 error messages. See one error message.
So that's saying it's expecting a parenthesis or
I'm just going to put a space in there real quick, just to make sure that's not our issue. All right, it was our issue, the if with the parenthesis right next to it. It wasn't getting tokenized. Well, no, it should have been. It should work just fine. Okay, well, there's our first expected opening parenthesis. Actually, let me do something here real quick. This will fix one of our issues here. I'm doing system.error expected. Let me do system.out. And I'll put a couple of asterisks in there. System.error is a different output stream than system.out. So that's why things were happening in a different order. Okay, so here's our if. That's why we were confused that it was associated with the do. System.err does not necessarily happen in the same order as system.out. So this particular terminal is showing us both of them in line, but not necessarily in the right order. So it saw our first if here, that we were missing the opening parenthesis. And then it did the opening and closing. So we popped it off, we checked what it was, then we matched the closing. This worked before, didn't it? Let me unerror our code here real quick. And we should have 1, 2, 3 if statements. Okay, so it read all of our if statements. Now let's break just the first one. Okay, first one's broken, but notice it missed an if statement then when we broke that first one. And I'm actually not sure why. All right, so somebody remind me at the beginning of class on Friday that our error message is breaking our second if statement. Write that down and that'll remind me. Japish? All right, I'll see everybody on Friday. Make it rain! Yeah, I have a guy on the scene. I have a guy moving. You see him? You bring in that thing? Yeah, he's firing missiles.
I feel like you need an epilepsy.